Hi everyone. Can everyone hear me?
Yes, we can.
Yes, we can hear you.
Okay.
Yes, we can.
Good. Okay, we are about to start. So let me introduce myself. A very good afternoon, ladies and gentlemen. My name is Max. I'm the sales engineer of TDS. Okay, today I will be your MC for today. As we are about to begin, please kindly be seated in front of your laptop or TV and get ready your snacks and drinks, as there will be no tea breaks in between the webinars, okay? And I hope everyone is doing well during this circuit breaker, and hope it didn't break any one of your stomach ways, okay? Because if most of the time we are just sitting, eating, and sleeping, okay? So I kindly sing your corporations. Switch off your Netflix or any YouTube videos to at least silent modes, okay? So there will be no unnecessary noise pop up during the webinar. Thank you for your cooperations. You all can see me, okay. So we are supposed to have a live seminar earlier this year, but due to COVID-19, it has been cancelled. But nevertheless, this does not stop us from trying. So this is our very first TDS webinar. So on behalf of TDS, I would like to extend a very warm welcome to all of you. Thank you everyone for allocating your time to attend this webinar. I hope you will learn something from this webinar today. We will be doing webinar weekly, same time every Wednesday, and it always starts at 3 p.m. So do keep yourself updated on our weekly webinar. Okay. We will have our Q&A sections after the last speaker has spoke. So in case you forgot about your questions that you want to ask, you may just type them inside the chat room. We will try to retrieve it one by one. Okay. So before I start the webinar, I would like to introduce our next week webinar, which I will share on the screen now. Okay, give me 1 minute. These are the program we'll be hosting next week. 7 of May. Okay, can you see the PowerPoint?
Yes, sir.
Okay, great. So for next week webinar, we will have on robot and also real-time robotics. Okay. As for real-time robotics, is a special guest that we have invited. They have invented technologies like never before. It's about real-time motion planning. As you have seen just now, I played that in the YouTube videos. It can avoid collisions of robots to robots as well as humans. So you can imagine how fast the processor has to be in order to react in real time. And they did it. So almost to all big brands of robots, especially for industry robots, because they always want to be collaborative with humans. Okay. So real-time robotics has the solutions, and it will be an interesting topics to learn about their technologies. So do make sure to sign up. Okay, the sign up link will be ready by tomorrow. I think our admin will send out by tomorrow. Okay. Okay, so that's all I want to share today. So I would like to invite the first speaker. Hey, wait a minute. Sorry. I think before that, just 1 minute. Okay, we'll start off with introductions from James. So James, are you ready? Regarding
Yes, I
your
am.
Sport Master. Okay, you may start sharing your screen.
Okay. My name is James Glover. I am responsible for the distribution and sales of Robot Master here throughout all of Southeast Asia and China. And what we have done at Robot Master is to make programming of robots as easy as programming a 5-axis milling machine. And it's not a simulation program, it is an actual programming. where we have taken our many years of CAD/CAM experience and applied it to robots. And we make all of the error correction and collision control, kinematic control, very easy for someone in the shop floor can manage it. And we work very closely with people like Keppel, Boeing, all the major manufacturers. And we have over close to 2,000 installations now, and we are growing radically. And one thing we have introduced recently is a complete automated learning system, perfect timing for the COVID, where you have a complete academy of how to learn and use Robot Master with more than 80 videos showing you exactly how to do it step by step. And this is a very radical change because most places do personal one-on-one training for these type of programs. And now it is completely automated where you can learn at home. And we have a program where you can do everything, but it just doesn't produce robot code. But you can learn everything at home. That's pretty much a quick description of Robot Master.
Okay, thank you, James. Thank you.
You're welcome.
Or maybe Robot Mon, are you ready?
Yes, I'm ready. Yeah.
Okay, maybe Robot Mon, you Shank. How do I pronounce it? Shanker, right?
Yes.
Shanker.
Yes. I'll
Okay.
introduce. Yeah.
Yeah, maybe you introduce about Robot Mon first. Thank you.
Yes.
While we wait for Joe, please.
Yeah. Hello, everyone. Thanks for joining this meeting, and I'd like to give a thanks to TDS for providing me this wonderful opportunity to meet all of you. So my name is Shankar. We are an IoT-based startup from India. We are building IoT-based Industry 4.0 based product and solutions. So RoboMart is one of our products which is used to monitor the UR cobots performance and its condition. People can use this product to get the real insight of what's happening in the shop floor and what's happening inside the robots. So people can extract a lot of information from the robot. Currently, if there is any problem with the robot, people cannot identify until the robot stops. RoboMon helps you to identify well in advance so that you can take a lot of preventive measure to avoid the unexpected shutdown from the robot, your cobot side. So this is the perfect timing for people during this COVID crisis or post this crisis. As a UR distributor or supplier, you may want to support your customers from remote. And as a UR customer or UR cobot users, you would want to monitor your robot's behavior or performance from remote. RoboMon has got all the features which you can leverage to overcome this current critical crisis. So we have a bunch of features. Probably in the next webinar times, I can explain to you, walk through all the features one by one. So thank you for providing this opportunity.
Okay, sure. Thank you, Shankar.
Yep.
So I'd like to invite our first speaker of the day, Dara, head of Southeast Asia of UR Robots. He'll be sharing with us the trend of the future collaborative robot and how it is about to change our current manufacturing system to a friendly robotic factories. So Mr. Dara, please. Thank you.
Thank you very much, sir. Hopefully at this point you are all seeing my presentation here.
Yes.
Okay, so look, Universal Robots is actually very excited about the future of robotics, especially as it obviously is a relatively new starter in the world of robotics, given we sold our first robot in 2008, but 44,000 installs globally now sees that we've got a nice foundation to build on, and we're looking toward the future, and it's exciting to see conversations like this put together. It's exciting to have the other speakers that are involved in this conversation as well, because every one of them I can see tying back to a robotic platform of some description, and we like the idea that we can be the next step in industry 3, 4, and 5. That's where UR is positioning itself for the future, and we're driving to meet that expectation. So the future of robotics is something that we have the future of automation and robotics is something we have a very strong interest in and a very strong understanding of where and how the world's moving, we believe. So just to clarify, mate, did you want me to just introduce myself at this point, or should I continue on?
You can continue.
No problem, Paul. Thank you. So, look, the standard issues that we see globally remain really unchanged. Certainly, COVID is driving some of these further, especially when it comes to the dirty, dull, and dangerous. Us trying to remove people from the dangerous tasks. We've seen a lot of use now around cobots being controlled remotely, or even from remote centres and driven on autonomous basis to do things like disinfecting or to help people in environments where there's a likely COVID exposure. So although UR is actively involved in doing that, we're also actively involved in how we can help the community. So we're not driving to profit off the blood, sweat and tears of people out there in the world at the moment, more just to understand how universal robots can be involved in making things better for people. And we've seen that already in a few different countries. But, as I mentioned, these things have not changed. The rising costs, the training costs, the cost of insurance for people. We continue to see a fluctuation in manpower, and I'll be interested to see what the other end of COVID looks like as well around manpower, as to whether we have an overabundance or an undersupply, depending on what people are doing. So that's still something that we need to keep ourselves aware of. And the consistency of output is something that everything is about at the moment, and certainly we're part of that. So to give you a quick understanding, and I'll do this briefly, I won't get into any of the technical specifications here because I don't have enough time for that, but additionally, I don't think it's relevant for this conversation. So this is the lineup of UR at the moment. So you can see we have a total group of robots that constitute 7. And realistically, 2 separate lines being the CB3 series, which is an older series that has some differences to the new E series, which was launched in 2017. The E series has some additional functionality that provides some benefit in terms of its ability to be tactile with the environment, and some additional safety functionality as well that's used. We in our region generally are focused on the CB series purely because of the cost base associated with that. But that said, there are many applications that we see the E series being used in the Asia Pacific region and throughout the world, purely because there are some additional features that live along that. What I can say is for the likes of polishing, fine picking and placing, things like that, where you need extra force feedback, the E series is a much better choice. Additionally, if you've got safety requirements around your factory that are to a higher standard than we can meet with the CB3, then we can certainly meet those with the E series. So the true benefit to cobots, coming back from the robot here that I'm showing you, is really around the simplicity. And that's our key market driver, realistically, is that we're simple to program, we're simple to install, we're simple to operate. And with what you can see coming from, RoboMaster just put forward some information there, having the ability to operate our robots in an environment that's uncaged, adding on all these solutions that, and quite a few of the guys on this conversation today that are presenting, in fact, are involved in our Universal Robots Plus group, which means they're certified to work with UR as well. So it's really exciting to see the extension of our base technology into other commercial operations. And how I see UR fitting at the moment amongst all of the conversations we're having today is the base technology. So we're the real world in terms of the software, and we're the base in terms of what the the end effectors and the like are capable of doing. Okay, so the extension of our capability through all of the other products you see here is something that's driving us into the world further and further into the world of things like 5G and artificial intelligence and that sort of thing. So we see a nice nexus right now of crossovers of different technologies that will give us an output that will help us in, again, getting people out of dirty, dull and dangerous jobs and moving them into jobs where they actually provide upstream or downstream value addition to robotics or to automation. So I mentioned a little earlier some of the things here that we kind of do differently, and I won't run through these here again, with the exception of saying, you know, industrial robots still have their place, and I regularly still guide people back to industrial robots when a collaborative robot is not a suitable application. I think all people involved in technology need to be capable of doing that, so that people get the right understanding of what's required out there in their businesses. And with that in mind, you know, there still is plenty of operations that require industrial robotics. However, collaborative robots are more and more becoming part of the everyday operation that we see in businesses and certainly in manufacturing. And we are stretched across many different market verticals, you know, everything from food and beverage through healthcare. You know, right now, healthcare being a driver as well. We're seeing more and more input into that area, but starting at food and beverage and finishing at automotive and basically everything in between. So we continue to see that growth happening for UR, especially on the back of the additional capability that's being driven in the third-party network and ecosystem that's around UR. The major costs involved in a traditional robotics or traditional industrial robotic installation is actually around the ancillary product and the ancillary installation rather than around the robot itself. I'll be very honest here. If you compare a collaborative robot side by side with an industrial robot of the same caliber in terms of reach and payload, you'll likely find that the industrial robot will be of a lower cost base. Now, I'm not ashamed to say that out loud, because we, as UR, have additional functionality, additional safety considerations that are already built into our robot. So you're not actually making an apple-to-apple comparison if you do that. These are the additional things that you need to build into that comparison on the dark side of this particular slide. And with these taken into account, you very quickly realise that the cost of owning an industrial robot to do the same job that's applicable for a collaborative is quite a lot higher, particularly driven around the cost of engineering and the cost of setup, which is where we very regularly excel around integration and certainly around post-installation in terms of repair and overhaul as well, is something that we're proud to say we're very low cost by comparison. But you'll see here on the white side, you know, that the end-of-arm tooling is something that I know will be discussed today as well with some of the other people conversing with you. And it is generally designed at a lower cost in comparison to the end effectors you see on industrial robotics. That's purely around the basis of the integration scenario. So it's the engineering costs that actually make it a higher expense when you talk traditional industrial. Now, the really exciting stuff for us, though, and the future of collaborative robots is built around what you see on the other side with some of the catchphrases. You know, we are coming into a time where you'll be capable of driving your robotic solution remotely using 5G because of the speed of the network that's around that. The artificial intelligence that you'll be exposed to today and also in the next webinar that Paul introduced before is something that is a very exciting future around how our robots interact with humans and how we can provide an outcome that perhaps traditionally we weren't able to with a dumb robot rather than an artificially intelligent robot. And there's a lot of things that come into the artificial intelligence around deep learning and machine learning as well, so we can truly understand what the humans are doing up front in that operation to turn that into something that can be very, very simply turned into a robotic solution. And again, we've seen some information around that today already. So these catchphrases are things that UR is looking toward and looking to understand how we can better provide a base solution to integrate with all of these open, new and exciting technologies. And one of the things that allows us to do that as a separate is the open platform that we have. And again, the ability to get a SDK, a development kit to allow you to develop things around UR is something that a lot of our traditional robotics companies weren't allowing people to do. And that gives us an edge in terms of allowing things to move into our network of ecosystem much quicker, and hence drive some of the outcomes that we're looking to achieve here, which is, again, all about ease of use and ease of setup and ease of programming. So, one of the other things I wanted to touch on here is about working where you are. So, simple integration, proven applications, and we're very adaptable. And again, if we look at COVID as a driving example right now, we're seeing robots being used in applications that are COVID dependent and COVID focused. That's great for right now, but what that means is in future, we've got potentially a vast number of robots that would not be reutilized for something else. One of the joys of, again, universal robots is that we're used in many facets in business or in manufacturing. And you can see a few things here around mobile, zero footprint palletizing, even upstream in terms of packaging and packaging, box packing as well. Is certainly involvement for us, testing, vision examination of systems. All sorts of things are really interesting to see where we're put. What is really interesting though for the future and the future of robotics is that we see more and more a drive toward potentially lower volume and higher mix. Even the headset that I'm wearing today, I can buy from a major manufacturer in 4 different colors. So more and more you're seeing this product mix change. That's interesting to us because we adapt very quickly, which you can see here by the gentleman pushing around one of our robots on a mobile base. This adaptation is something that I think the future will drive as well, because we more and more want our McDonald's burger to be individualized to what we want. And I think we're going to see that driven more and more throughout manufacturing as well. So that actually sees me finish up, because I have 15 minutes here to chat, and I wanted to leave a little bit of time at the end to make sure that there wasn't anything that I missed, that anybody wanted to cover. We do have some question time at the end as well. I know that's been designated. So if you have anything now, I'm happy to answer, or we can continue to roll on if you like.
Hi, Derek. Okay,
Hi.
so let me see. Okay, yeah, we will have a Q&A right at the end of our last speaker.
No problem, Max.
Okay, so that's all for slides, right? Okay.
That is it for me. Thank you.
Hey, so thank you, Derek. That was interesting. Thank you.
No
So
problem.
I'd like to invite the next speaker, Renata. Are you ready?
Hello, good morning.
Hi, good morning, good afternoon from Singapore.
Oh, good afternoon.
As for Renata, I believe she's right now in which part of Europe?
I'm actually based in Budapest, but Ease Robotics is based in Denmark.
Denmark. Okay. Okay.
That's correct.
Okay, you
Just
may
one
start.
second. Let me try to share my screen here.
Yes, we can see your screen.
You can see my screen. Just one second.
So just a little background about Renata. Okay, Renata, to the audience, Renata is responsible for marketing and communications for Easy Robotics. She has vast experience in robotic segments, knowing which robotic product suits the best for the process. So when it comes to customer project, she's always eager to support. Today, Easy Robotics has increased their product range from machine tending to palletizing and now AGV as well. So Renata, are you ready? I will leave the rest to you. Okay, you may start.
Yes, sure. So good morning, everyone. My name is Renata. I'm actually part of, as Max just introduced me, of Easy Robotics, and I'm responsible for the marketing, to make sure that, all the products are well exposed and we clearly pass our message. And so I will start here in just 1 second. Do you see my screen, Max? Oh, yes, there we go. All right, so Easy Robotics, it's a company located in Sonderborg, which is a little close to 45 minutes flight from Copenhagen. And we are, we started in 2014, and the goal is to actually be the world leader innovator of cost-effective multipurpose standard robotic cell. We do believe that a robotic cell, it's a combination of course, the robot, as Daryl mentioned, but also the end solution to the customer. Now, up to date, we have deployed 400 robotic cells, and we have a little bit more than 60 partners around the world. Okay, just 1 second, we have some delay. Oops. So our product line overview, it's really separated between mobile, the Profeeders and the Palletizer. With the mobile, we partner up with MIA, which is the mobile platform, and we have the ER200. And you can see here in the picture, it's actually based on mobile application to support the universal robot. And for the Profeeders, it's a CNC machine more focused product where you can have parts and let me see here, and do the CNC machine processes and machine tending. And then we have the Palletizer, which is basically doing palletizing. We introduced last year, in the quarter 4 2019, we introduced the new products, which is the Profeeder X, the Easy Pedestal, that it works together, can work together with the Profeeder X and the Profeeder Compact. And of course, since we are very focused on the CNC market, we have Ease Door, which it can be placed in any CNC machine doors. And if you look a little bit into our product line for the Profeeders, we started with the Profeeder table, and you upgrade a little bit for the Profeeder Lite, where you can see the trays and you can do much more processes. And then we came with the Profeeder, where you have a cart, and you can basically be a mobile application where you have the tray moving to one place to another, and then from station to another station. And then we have the Profeeder Q, which is a much, let's say, a little bit upgraded version, a little bit more smarter, where you can have actually 4 shapes operation with different trays. Okay, just have some delays on the screen changing. Max, do you see my next screen actually? Okay, I got it.
Yes, Profeeder X and Compact.
Okay, perfect. So this is a little bit more introduction between on the Profeeder X and the Profeeder Compact. And if the Profeeder X, you can run here a little bit video, just for you to have an idea how it actually works. It can be airlock system that comes with an airlock where the operator won't be able to easily, unlock the trays, and that makes a little safer the process. And of course, we have match lock system that can be easily accessed, and then can be manually unlocked. So here in the video, you can see different trays with different parts. Those trays, they can be customized to the parts, and then we're talking about here dimensions as height, weight. And what is simulating here is that in the other side, the operator will be able to unlock the trays and then move to once the metal is already milling or grinding to a final process. Okay, Okay, in the Profida, it can be placed, it's a placement control and designate compartment Modbus, and it can be with diodes as well. Okay, so I have here some dimensions. The dimensions are pretty much standard, and the idea of having the Profida X is to have a better, more, Profida that can actually assist you with the machine tending, but we have several trays, and then increasing the cycle time for the process. And a little bit about the Profida Compact. The Profida Compact is basically the same as the Profida X. However, it's a little bit more compact on its dimensions, and it has less trays, but however, it can be fitted anywhere in the factory floor. And the idea behind it is to to save space on the factory floor, and then we can upgrade it to be a movable machine by placing the wheels, and the robot pedestal can be placed next to it. And we have a little bit here about the docking system, and you can have an idea how it actually works with the trays. And I'm going to play now a video of a case story that with a Profida work with a CNC machine. It's from one of our partners in the United States, and it's together with Hugo. So as you can see, the robot is easily sliding the trays, picking up the parts, and then placing the CNC machine. And once this process is done, the operator comes to the other side and unloads the parts and load the parts with new fix as well. And then there comes again the operator once again comes to the second tray, and then simultaneously. And that's what I was talking about, the match locker system, where you can press the button. Right, and then if you see a little bit, if you think a little bit about how can you actually put the machines together and integrate the whole robotic cell, here would be the CNC machine, the robot with the easy pedestal, and you are here, and of course we have some Profida Compact, or could be a Profida X as well, and that you would have a full robotic cell ready to start any process. And a little bit about the easy pedestal. The easy pedestal is just a compartment that we recently, created to come together with Profida Compact and then deliver better application in a whole. And a little bit about the easy door. The easy door is it's mounted on the CNC machines, and the length it's 700 mil. And it's up to 180 kilogram doors, and it can open and close. And then we connect as well with the robot. We understand once the process, you have to place the metal or the parts in the machine, and you have to open and close. And here I have a little bit more specification of it. Okay, where these doors programmed, and it learns its normal movement of the door. And then it has some safeguards, and then we will understand once it has to stop, and then we will decrease the speed, and so on. And a little bit about the Palletizer. The Palletizer is It's as you see, it's a floor level palletizing, and it can be loaded with transfer station from conveyor to fixing units. And a little bit more specification of the palletizer. It comes with a configurable buttons, and it comes with a reset buttons, and it has also optical sensors, and can obviously be moved away on the factory floor, and it can be placed to a pallet. It's a standard size pallet, as you see here in the picture. Okay, just trying to go to the next slide. Max, would you help me here? Do you see the next slide?
No. Now I'm seeing the palletizer slides.
Okay, you're still in the palletizer. Okay, just sorry about that. Okay, I got it. And then we have a new version of the ER5, which is the ER Work XL, and this one is to be fitted with UR series, UR10 series, and it comes with the trays, and you can do let's call it a little bit more as a small process for CNC machine. This is a good option if you'd like to start understanding, how to put a robotic cell for CNC, and then you don't want to jump already to the Profida X or Profida Compact. You could easily use and move the mobile platform around the factory. And then we have also the Profida Stacker. The Profida Stacker it's a very interesting product. It simultaneously will feed the pieces, and I want to show you a small animation so you can have a better idea. So as you can see here, the pieces are placed, and then the tray will move up, and then where you can unload the pieces, and then once again, you start it. And another great product is the Easy Palletizer XL. And then we have this on the roadmap, or we want to launch it soon. And the idea is to also support not only collaborative robots, but industrial robots. Industrial robots heavy duty. And then where you can see that the pedestal is larger, but the concept with the palletizer is basically the same. I mean, the current palletizer that we have. And we are eager to support different robots. UR, of course, it has been one of them for the last months, but we are looking into different robots where the process can be automatized much better. And then thank you. If you have any question, I think I'm a little bit over 2 minutes over time.
Okay, thanks, Renata. Q&A will be during the last sections of the webinar, so please stay back first.
Sure. Thank you.
Okay, so thank you, Renata, again for the great update about Easy Robotics products. So next, I would like to invite our next speaker. He has been working with 3D vision systems for over more than 10 years and 3 years at 3D Pickit. His job is to give eyes to robots to make them smarter and more adaptable to the environment. Definitely a very experienced 3D vision guy. So let's welcome Sam, Technical Manager of Pickit 3D. Sam, are you ready?
Yes, Max, I'm ready. Do you see my screen?
Yes, I see it. Thank you.
Oh, okay, thank you everyone for joining the webinar. I will try to hand out as much information as possible, and I think TDS is the right company afterwards for you to contact and have more information or bring you in contact with me. So I'm not going to talk too much about Pickit, but basically we have a headquarters in Europe. We have a next semi-headquarter in Seoul in Korea, and then we have a new office in the USA. We have 50 resellers and basically cover most of the industrial markets on the world. What are our key accounts? So mainly everything that has to do with manufacturing at this moment. So we're not very big in logistics, but as you see here, most of these companies are manufacturing companies. So they make products. Let's dive directly into the most important thing. So how does 3D vision works? Most of the people who have experience with robotics and industrial robotics have a lot of experience with 2D. They also know the shortcomings of 2D. So a 2D system is light dependent and is also shape dependent. What is the biggest difference with a 3D system? As you can see here in the image, a 3D system allows you to find shapes and not color. So it starts to look for shapes. So what you see here in the image are every color represents a model, so a shape that is projected onto a point cloud. So inside the blue box, you have gray points. The gray points is the point cloud. So the point cloud is what a 3D scanner captures in. And what the software does is it will fit that model, so that 3D shape, onto the point cloud. If an object is recognized as a good fit, that means that the object can fit, then you get a color information and you get a pick frame. What is a pick frame? It's a X, Y, Z orientation. So you have a blue axis, that's the Z, red is the X, green is the Y, and the location of an object. What is the benefit compared to using 2D information is that the products can be touching, the products can be overlapping, and the products can also be on top of each other. So it opens a lot more possibilities. What is the Pickit product as a product? It's software with a processor, a camera, or a scanner, depending on how you want to call it. And then you have a user interface. So very shortly, how does a standard 3D vision system, not only Pickit, but most vision system works, is you have a robot or a PLC who's the master of the application. What will happen? Your robot will ask a question to the 3D vision system, here the Pickit system. What will the robot ask? Hey, Pickit, can you find me, for example, a gear? What you have to do in the Pickit software is you have to tell the Pickit software, if you get a request from the robot to find a gear, I want you to look here. So where to look? I want you to look for a gear. So you have to train him or explain him how a gear looks, build a model. And the third step is you need to explain, if you find a gear, how will we approach or how will we grab the gear with the robot? So you always have 3 questions that you need to fill in or you need to answer into the user interface. Pickit has integration out of the box with any major robot brand. And it's always the robot that's the master. The robot asks the correct question and the Pickit will give an answer. Yes, I found something and its location is here and this is the way to approach it. So as you hear, the software is very important. So the software makes your robot smart. The software that we have is easy to configure and it's all done to a web interface. So what you see here is you have a 2D image, you have a 3D image, you have point clouds, you have clustering, you have objects, then you have a configuration, calibration, region of interest. So there's a logic step and you start with the first step. You start with the configuration. So first you're going to explain the camera where to look. Then you're going to explain in the software what to look for. Next step is you're going to explain how to pick it up. And these are all the steps you have to do for the robot to become smarter and to be able to pick objects out of a bin. We have a camera range depending on what kind of application. So our Pickit L camera is only focused on depalletizing, but I'll show some short videos later. Then we have a Pickit M that's more for simple geometric shape like billets for machine tending or for stamping applications or forging applications. And then our HD camera is our standard camera that we use for all mechanical parts with 3D shape. There is, of course, a reason we're in this seminar, and that also has to do with we're very focused on the collaborative market. Why? Because we believe in the advanced technology and also in the kind of customer that works with collaborative technology. The customers who work in collaborative technology are often the guys who are experiencing out of their comfort zone. They're doing experiments, they're trying new things, and that also helps us. So we made for the UR a UR cap version 1, and now we have a second version. The second version allows you to not even program a lot anymore in the UR. You can just say, do I have overlapping objects? Yes. In the UR, Do I have a vacuum gripper or do I have a gripper? And you move forward. By doing this, you can have a pick and place application within a few hours. What is very important for us is our support. So we have built-in support tools into our software. There's this yellow button that I'm showing here, and that's basically taking an image, and it's taking a screenshot. What can we do with a screenshot? It saves the point cloud, it saves the settings of a system, and it can be downloaded, and it can be sent by email. So your system doesn't have to be online for our support group to see the same as you're seeing under the camera. Why is that important? Because it helps us understand what you're doing. Different products have different reflections. So there's a lot of ways of supporting people, but the only way, if you work on vision, is to see what's under the camera. That's why we have an online support tool and an offline support tool. So coming back to how do you set up an application, the first thing you're going to say is where to pick into the software. So you're saying, this is my ROI box. Why is it important to set a ROI box? Sometimes a camera can see a lot, but you only want to see what's inside your bin. The next step is, what do I want to pick? So you're going to teach a model. Either you upload a CAD file or you use the camera point cloud to build a model of your product. Then you're going to explain, how do I want to take this object? And why is it important? Because sometimes you don't want to take the object in a hole, but you want to stay on a flat surface. Or sometimes the center of gravity is totally left or right, so you want to move there. And the last step is the execution logic of your robot program. So where are you going to drop off the part? Where are you going to move the part to? Do you want to use a fixture? Are you putting it on a conveyor? What is for us very important in the 3D vision market, and I think for everyone, is there are a lot of typical applications. So what are typical applications? They're basically solutions that have been proved out, that have been tested, and that are running in production in multiple locations. Why are we trying to help people who are new into 3D vision to work on these kind of applications? Because it brings a lot of confidence, and you can build up knowledge in your factory or in your company about 3D vision by starting easy. It's basically learning to walk before you run. So what are these kind of applications? We have 5 groups of applications that work very well with 3D vision. So the first one is cylinders. The second one is rings and discs. Then we have flat and sheet metal, but I'm going to skip that one. We have semi-structured, and we have depalletization of full layers. So I'll run some videos so you have an idea. So why are cylinders very easy for 3D vision system and for bin picking? Because they don't have a 360-degree orientation around their length axis needed. So that means if you use a magnet like you see here, you can pick most of the objects out of the bin. This helps you in the complexity of your robot motion programming. Why is that? Because you can approach the cylinder from any angle, 360 degree around the length axis. On the other hand, the Pickit systems are very well built to find cylinders. The other video to the right, this video is basically showing cylinders, and it's a typical task that before 3D vision was a very tedious, boring task for human workers. So what are we doing here? The 3D vision system is guiding the robot where to pick the cylinder. And then we have a 2D vision system with lasers as a quality control station. That's what's happening here. These are connectors for aerospace, and every connector needs to be qualified before it can go to the end customer. So they need a 100% check rate. The reason to automate it is to eliminate a human error. So the 3D vision locates the cylinder, and the 2D quality control system does the check. What are more cylinders? Here, it's just a typical mechanical part that's been dropped into a fixture, and then it will move into the next step in the process. But these cylinders are very interesting. There is a huge market of machining, stamping, milling that are all buying steel billets out of a bin. Why do we want people who work on these kind of applications? As you see, we design a gripper, we know how to program a robot, and we have a complete solution. So we can help an integrator or an end customer to go from A to Z and not only focus on the vision system here. As you see here, this gripper has flexibility along one axis. And why is it? It has to do again with how do you take stuff out of a bin. Here, the robot can approach straight down. That also means this billet that is pointing towards the bin, if the robot can go straight down and the gripper can have some flexibility, we will be able to pick it. If we want to pick this billet and the gripper will have no flexibility, we would collide with the side of the bin. Our software can calculate the collisions and calculate what object is free, but if your gripper doesn't have a good design, sometimes the bin cannot be emptied. Again, that is why cylinders are a good object. What is the next group? The next group is rings and discs. What do we see? There's a lot of bearings, there's a lot of big bolts, big washers, those kind of things also in manufacturing. The benefit here for using 3D vision is that they tend to lie flat in a bin. And most of the time, rings, they have a hole in the center. So disc brakes, the discs, the raw discs that need to be picked, bearings, all these kind of things are rings and can be picked very easy within the center of the hole. So here you see coupling plates, you see bearings, and you see the disc brakes. These are typical rings and discs applications. Then we move into the more complex shapes. And what happens with complex shapes? Complex shapes that are in a semi-structured way. Like you see here, these are CV joints parts. There, the 3D vision system can help with doing many steps. So the parts can move. The parts have a different Z height information, but with a 3D vision system, you can allow your robot to pick them all. Even here, you have the parts and then you have an intermediate layer. We can get both the parts out and the intermediate layer. Here, it's an assembly of a subframe of a car, and you have different parts stacked in a semi-structured way. The parts move on these carts when the carts move around, but the 3D vision helps the robot to be guided to the correct position to pick each part. So the moment you have parts in a semi-structured way, this means that they're not fixed in a structured fixture like the easy robotics feeders have, but they move in carts or they move around. A 3D vision system, again, can be very helpful. And then the last group, but also an important group, is the depalletization of boxes, bags, and I'll keep the last video to explain something else. So here you see that there's one type of box in these carts. And what Pickit can do is he can just find one type of box per pallet very easily. So it's depalletization. While here, these are bags of flour. The Pickit system is used to locate each bag and to do the depalletization of bags. These are all very tedious tasks and very wearisome tasks on the back and very heavy tasks for human workers. And then the last video, that's an interesting one. Here we use the capability of the robot and the Pickit together in a good way. So what do we do here? We go up for a detection. So the robot is going to a detection position. He's asking Pickit, can you detect and can you find me the buckets? What Pickit does is Pickit takes an image, processes the image and says, okay, I'm finding all of these buckets. What the robot then does is he's not asking Pickit for a new detection. He's just asking, hey, give me the next buffer, pick frame, and give me the next one until Pickit has none. When Pickit has none, the robot will get a no from Pickit. The robot will move up to the detection pose again and takes a new image. If the Pickit says, I cannot find a bucket anymore, the robot will switch and will ask Pickit, if you don't find buckets, can you find me a big rectangle? That's what's happening now. He gets a no, he switches the program file, and now he finds a rectangle. So it's important to know that if you have a robot that asks the right question, your robot can become very smart. You have an extra added sensor that can not only find objects, but also can tell you, I don't find anything, or maybe I can find something else. But that's all the robot logic that you use. Where can you find a lot more information? Support.pickit3d.com is our support technical base. So it's full for each robot brand, how to set up Pickit, how Pickit works, all the technical data is here. And then we have a YouTube channel with online videos. And that's my presentation, Max.
Hi, Sam. Thank you. Okay. It was nice to know how Pickit engine works. So it's finally time for Q&A. If anyone has any questions, please raise your hand by clicking on the button, or you may just type inside the chat room. I'm sure the speakers will be pleased to answer them. Okay, let's see. Where is the hand button? Okay, the hand button actually next to this raise. You want to, Bruce, you want to say something? How does, okay, we have another one before. How does ProFeeder communicate with CNC machines? Okay, maybe, okay, Hi, Renata. Are you there?
Hello, Max.
Yes, we have a question from Go. Mr. Go.
Okay, sure. Okay. So the communication is through Modbus, and then basically it's the robot and communicate with the machine, the CNC machine, and then the ProFeeder communicate with the robot. I can also send more information. I think that you're going to send more information afterward on the specifics of the.
Okay.
You're welcome, Ken.
Okay. So let me see. I think the next one is it Bruce? Hi, Bruce. You have anything? Or you want to turn on your mic? You may unmute yourself. Let me see. I want to ask you, system suitable for vertical farming. Vertical. Hi, Bruce. I think I can hear you. Your question is about if the system is suitable for vertical farming. Hi, Bruce. What kind of vertical farming are you referring? I'm referring to the vision systems. Do you mean by using the vision systems to detect something like the plant?
Okay, hi Bruce. So
Oh,
yeah. Max, can I explain to Bruce?
Yes, please. Yeah, I think he's
Okay.
asking like whether to can they use like 3D visions to detect the growing of process of the plant? Because in Singapore, we have like a project, whereby most of our parking lots soon will be growing vegetables on top of the parking lots.
Yes. Okay, so our main focus as a 3D vision system is focused on manufacturing. That means shapes that are very clear defined. So rings, bearings, those kind of things. But we have been working with some R&D centers where they pick, for example, apples, because an apple is a sphere. It's a geometrical shape, or bananas or melons, those kind of things. What we also have been asked is if we could help people with vertical farming about picking a plant when the flower is ready. So when the flower is big enough. And that's something we cannot do because the flower has no distinctive shape, not even a general shape that we can fit. So an apple can be a little bit bigger, a little bit smaller, but it always resembles a sphere, while a normal flower can be any shape and any size. So for flowers, no. If you say we want to pick a kind of fruit that has a certain shape, then we can be helpful, yes.
Okay. I think that explains. Okay, thank you, Sam.
Certainly on the UR side around that as well, we have already been used in applications, farming applications, both horizontal and vertical. So it's certainly not foreign for us to be used in that way as well.
Okay. Okay. So I think the next question is to UR. Daryl, are you there?
Yes, I am, sir.
Yeah, okay, good. I think there's a questions asking, as UR consider expanding into industry robots field?
So the short answer to that is no. We haven't considered, to my knowledge, to move into that field because we are really focused on collaborative robots and focused on being the part of a significant part of the future of robotics. That said, though, in many applications where an industrial robot is used, a collaborative robot can also be used. It's just not used in a collaborative nature. So, for example, we do have multiple robots, hundreds, if not thousands of robots globally that are still used within a cage, like an industrial robot is, which allows us to increase the speed of operation and hence the throughput as well. So there is some precedence there, or some operations already globally that are running collaborative robots in an industrial setting, which is actually quite a good thing. And I'll use this for one reason, is because industrial robots, when you service them, are still potentially dangerous items. The last person that was hurt by a robot was actually injured due to the robot falling on them during a service. So industrial robots will continue to have that, whereas collaborative robots, even when you're inside the cage, the safety protocols remain.
Okay.
Yeah.
Jared, I think there's another question for you as well. How can UR robot accelerate productions and social distance between workers after the circuit breakers in Singapore? That's a very good question right now.
It is a very good question.
Yeah.
I think this is a question relevant for most countries, actually, not just in Singapore. We have been approached already reasonably frequently around this conversation, and the ability for a collaborative robot to be effectively pushed in between two humans and provide the social distancing requirement is something that we're really quite well positioned for. So it is something we're looking at in terms of how we can best fit with this, and the social distancing aspect has more to it than just keeping a distance. It's also around the potential for transmission on contact of different products. So we'll continue to work on that as well and make sure that we have the capability. But I see in future, until we have a cure for COVID or a vaccine, we're going to need to include social distancing in factories as well. And certainly the ease of setup for UR helps with that, and the ease of use of all the other, the guys that are involved in this conversation, guys and girls, sorry, that are involved in this conversation, give us extra capability to do that as well.
Okay, thank you, Daryl. Okay, the next question is to Sam. Hi, Sam, you ready? You there?
Yes.
Okay, there's a question asking, is there any possible collaborations between the Pickit and the IIoT, Internet of Things? Can we like one day, this
Yeah. So
Pickit data be transferred to internet?
it's a very good question, and so I think 5G will be the key driver there. So at this moment, we have a lot of data, point clouds. Right now, we only process the data to find a geometrical shape, but the data can be used at some point to qualify objects. So right now, we don't do quality control. We leave that to 2D vision systems and fixtures. But the idea is at some point to get more quality control and more data out of the system. So right now, there is from Robotic or a system where you can log all the data that's in a UR. But it's all done by wires and cables. I think once 5G hits, our data could be implemented into many other systems to add value as how many peaks do we have? How many did we take per second? What are the cycle times? How is our production running? All of these kind of things. But right now, at this moment, we're not using that data. There are some projects with 5G where we are included on the vision side. But I think, we need to see where 5G will bring us to send data in factories remotely.
Okay. I think there's one more questions. Can 3D robots segregate more than 2 items from the bin with random item and
Yes.
put them on separate bins? I think he's asking like a bin
Order,
with random item.
order picking. Yeah, so it's order picking. It's a standard logistic question. So you have a bin with, let's say, to make it simple, you have cylinders and then you have square blocks to make it easy. You need to have the cylinders to the left and the square blocks to the right. It's basically robot programming. So your robot will ask the vision system, find me cylinders, and the camera will keep finding cylinders. And if he doesn't find any cylinder anymore, you will ask from the robot, hey, vision system, can you find me squares now? And then you will find squares. And then if you don't find squares anymore, you can go back to the cylinders until you find. So you can separate certain kind of objects in bins. There's a big difference. We do get requests on, can we separate washers and bolts and nuts? These are very small and the differences are very tiny, and that's something we don't do. There's enough mechanical ways to separate these. But for example, there's also the recycling industry, and their vision systems, 3D vision systems, are very useful to separate bigger cans from smaller cans, bigger plastic from smaller plastic, those kind of things.
Okay. Sam, another questions thing from SG Ng. How fast to set up and 3D visions for part to detect? Hey, by the way, can you Sam, can you just turn on your video so that we know it's the Pickit Sam is speaking, in case someone is not sure what we are talking about.
Yeah. Okay. So
from Sam, yes. Okay.
Yes. So a 3D vision system setup can go really fast to do a test or proof concept. So for example, if you have these kind of parts, if you would ask somebody from our company to set the vision system up and to locate these parts, it will take no longer than 1 hour. Why? Because we know the system and we know how to find these parts. A person who had an introduction training into Pickit will be able to do it in 2 hours. But that's only finding the part. So finding the part, locating the part, and setting a pick frame. But then you move to the next step where you say, okay, I have it now in my lab. I can find the parts, I can pick the parts, but now you have to move into production. And that's a big difference. So everybody says vision systems are very easy to set up. That's true until you have to go to production. And then there is a big amount of uncertainty in a bin. And that's when you need to start robot programming. So the vision side is very quickly, but the robot programming has to be done on a good level. But that's something we can also guide you to. For example, if this part is close to the side of the bin, you cannot go in the hole anymore. So you need to once you encounter that, you need to think about, okay, how are we going to tackle it? So you have a part that's close to the side of the bin. You have a pick frame only in the hole. What you need to do is you need to check if your gripper can be able to pick the part from the side. If that's not possible, then you have to check if your robot can push the part flat, and then you can go in. So these kind of movements and these kind of questions have to be programmed into the robot. But they're all possibilities now. And all these possibilities make it very complex for somebody who's new to understand what the system is capable. So that's why we want to help as many customers as possible to start with the typical applications, because we have a broad knowledge on how to do that. So I would say setting up a vision system very quickly, doing some proof of concepts, testing it very fast. And then I would say going into production, it's the same as going with any other system in production. You need to test and you need to spend some time on testing and fine tuning it.
Okay, understand. Thank you. One more question. I think, will Pickit 3D system be compatible with all robotic arms?
Yes. So we have integration into Kuka, Staubli, ABB, Fanuc, Yaskawa, Techman, Universal Robot, Albo, whatever. But we also have a robot independent interface. So that means we communicate over TCP/IP protocol, what most of the robots have, and all our communication protocols are documented on support.pickit3d.com. What does it mean? You can find the whole communication protocol and you can put it into a PLC or you can put it into any robot.
Okay, so it means they will have to write the code themselves.
Yes. Yeah.
Okay. Okay. Do we have any more questions? Right. Thank you, Sam. Okay, if not, personally, I have questions for Renata. Are you there, Renata? Hi, Renata.
Max.
Hi, yes.
Yeah.
I have a question. I'm interested in your ProFeeder X. May I know if the height in between the trays can be adjusted? Let's say if I have parts that is taller or shorter, you know.
Yeah, in fact, all the ProFeeder, they're pretty much customizable, right?
Okay. Sorry, Renata, can you turn on your video so we know it's you speaking?
Do you hear me?
Yeah, I can hear you. Your video. Yes.
Can you hear me now?
Yeah.
Okay. So yeah, so the trays are pretty much customizable with the height of the product. I mean, the parts, we say.
Yes.
And you can even make smaller to fit more parts. You can make a little bit shorter to, to fit more trays. And I think that's the pretty beauty about the ProFeeder.
So you mean the height in between the trays can be adjusted accordingly? Is it easy to adjust?
It can be. Of course, it needs some customization for it, but it is possible. We do have the pre-standard, from ProFeeder table to ProFeeder, the series, right? The ProFeeder table, ProFeeder Lite, and a ProFeeder, and then with 6 trays, and then we talk about 10 trays now. But yes, it's possible.
Okay, and roughly what is the payload per tray?
I'm sorry?
The payload, how much per tray can it carry up to?
It's pretty much up to 100 kilograms, if I'm not mistaken. It's pretty robust metal dense material, so the trays can really handle a lot of weight. The question is really the process, right? How, if you think about all the parts combined as the final weight, or you think about the parts itself and how much can the robot handle, and then therefore the payload for the gripper and so on.
Okay, thank you, Rita. Thank you, Renata. Thank you. Okay. Okay, so do we have any more questions? Let's see.
From, I think Max Dalmia is referring to Pickit. We don't support. Yeah, we don't support Modbus. No, we only have TCP/IP communication protocol.
Which is okay, TCP/IP. Okay, understand.
Yeah.
Okay. Any more questions? Okay, if not, we have a form. We have inserted a form inside the chat group. So kindly click on it and tell us your feedback about this webinar, okay? And for your info, we will have a IoT webinar in the 3rd week, okay? So we will send updates again to everyone again, okay? So if not, thank you everyone. We have come to an end of our webinar. Thank you very much for your participants. Before I end my day, make sure to click on the form, give us some feedbacks. Thank you. I hope you all enjoy the programs. Okay, if anyone has any further questions or inquiry, do email us. We will approach you individually. Okay, if not, thank you very much. Stay home, stay safe. Hope we will see you in person soon for our live seminar. Thank you.
Thank you all.
Hey, thank you
Thank
all
you.
speakers as well.
Bye-bye.
Thank you. Bye-bye.
Thanks, Sam.
Thank
Thanks,
you.
Ian.
Thank
Bye.
you to all the
Bye,
speakers.
Max.
Thank you. Thank you,
Yeah.
Max. Thank you, Paul.
Bye. Bye.
Thank you.